Chapter 9, we're going to transition into looking at properties of transformations. And the good news for most of you is that this is review material. We've discussed these transformations a little bit throughout first semester, and now we're going to dive just a little bit deeper into some of these ideas regarding transformations. And so specifically today, we're going to look at translating figures and using vectors to translate. So first of all, we have something that's called an isometry, and very simply an isometry is a transformation. Alright, so an isometry is a transformation that preserves length and angle measure. Okay? In other words, it's a congruence transformation, really is another way of saying it. And we have three types of transformations. You should already know these. You have a translation, you have a reflection, and we have rotations. All right, and so those are the three types of transformations that we're going to talk about. And again, today we're looking at the translation. And translation is an isometry because your shape does not change at all when you translate it. All right, so first of all, we have to graph the quadrilateral ABCD with vertices at -2, 6. So -2, 1, 2, 3, 4, 5, 6. So there's point A. Point B is the point 2, 4, 2, 4. So there's B. C is the point 2, 1. There's C. And D is the point -2, +3. All right, so here is our original quadrilateral. It says find the image of each vertex after the translation x plus 3, y minus 3. And if you remember from first semester, all this means +3 means go to the right 3 units, -3 from the y means go down 3 units. Okay? So the first thing we got to do is just translate these. So you could go off of the graph, or we can use these, the coordinates here. And so we have -2, 6. So when I add 3 to my x, I get +1, comma, and then I got to subtract 3 from my y, so I get +1, 3. If I look at my b, add 3 to my x, subtract 3 from my y, add 3 to my x, subtract 3 from my y, add 3 to my x, subtract 3 from my y. Those are my 4 new vertices. All right, so I plot the point 1, 3. That guy there is A prime. Okay, we always use prime notation for the image, for the new figure. Okay, 5, 1, 1, 2, 3, 4, 5, 1. That's B prime. C prime is 5, -2. And D prime is 1, 0. So the red dotted figure here would be our image, our new figure after that translation. Again, this is nothing new, so hopefully you're feeling pretty confident because you should already know this stuff. It says write a rule, so now we're just working our way backwards. So the way I would do it is I would write down my original coordinates. I have A, I have B, and I have C. A is the point 1, 2, 3, 2. B is the point 1, 2, 3, 4, 5, -1. All I'm doing is looking at the graph here. And C is the point 3, -1. And when I do this transformation, A prime, B prime, and C prime are the points. Let's see here. A prime is 0, 0, 4. B prime is 2, 1. And C prime is 0, 1. And I say, okay, how do I go from A to A prime? Well, if I look at my x's, I have to subtract 3 from my x, and I added 2 to my y. If I look here, subtract 3 from my x, add 2 to the y. Subtract 3, add 2. Okay, so your rule would be you're subtracting 3 from your x, and you're adding 2 to your y. All right, and that's the way we would write that rule. Excuse me. Now we're going to discuss this idea of a vector, okay? A vector is a quantity that has both direction and magnitude. Okay, and so the way we would read it, we would call this guy here vector FG. You always start at the initial point. When you're naming it, you start with the initial point, which is the starting point. So that point here is F. And you always end you name your vector, your initial point, and then your terminal point, or your ending point, which in this case happens to be point G. Okay? And the big thing here is that we're going to talk about component form of a vector. All that means is we can write it using this notation, where the first number is the horizontal component and the second number is the vertical component. All right, so in other words, when I look at this vector, to go from F to G horizontally, I start at F, I got to go right 1, 2, 3, 4, 5 units. Okay, so I know that if I go right 5, that's a positive 5 units. And then I got to go up 1, 2, 3. Again, that's a positive 3. So this here would be the component form of vector FG. And we're going to use this now to do some translations. Okay, this idea of component form. So first, name the vector. Start with your initial point, G, your terminal point's H, and you just put the little arrow over it. Okay? That indicates it's a vector. As a matter of fact, I believe the book might, instead of having an arrow on top and on bottom, yeah, it's just an arrow on bottom, because otherwise this would be array. Okay, I made a mistake there. So that would actually be array. So for a vector, what we're going to do is we're going to have GH, and instead of going top, we're just going to do this, just the top. That tells me it's a vector. Component form, horizontal, right? So I got to go right, 1, 2, 3, 4, 5, right 5, down 1, 2. That would be the component form of the vector. For this next one, I would just pause the video, see where you're at, okay? Name it, and then give me the component form. So the name, vector RS, component form, I got to go left, 1, 2, 3, 4, 5, 6, 7, left 7, and then I don't have to go up at all. Okay, so that would be the component form there of that vector. Again, horizontal, then vertical, X, then Y. All right, so the vertices are A, B, and C. Translate the figure using that vector. So I got to graph the original. So 0, 1, 2, 3, 4. That's A. B is 1, 2, 1, 2, 3. There's B. And then C is the point, 1, 0. Okay, so A, B, C here. Triangle ABC is my original. And now I got to use this vector. So remember, all this guy tells me is, since it's negative, left 4, and that 1 tells me up 1. So now it's a counting problem. I go to A, I go left 4, 1, 2, 3, 4, up 1. There's my A prime. Left 4 from B, 1, 2, 3, 4, up 1. There's B prime. Left 4 from C, 1, 2, 3, 4, up 1. There's C prime. And so now, again, the red dotted shape here, or the red dotted triangle, would be my translated triangle. Okay, so again, it's the same problem. We're still translating, except now we're using vectors to tell us the rule instead of writing it all out. Okay, and then the last example here is, again, just some vector problems. It says write the component form of vector AB. You can read all this stuff, okay, up here. But the thing is all of that is in, the information that's in the diagram. So it says write the component form of AB. To go from A to B, I got to go right. I know the x-coordinate here is 8, so I have 0, 0. I got to go right 8 units, okay? And I'll have to go down 12. Okay, so the component form is just going to be positive 8, negative 12. Write the component form of BC. Okay, to go from 8, negative 12 to 4, negative 12, I got to go left 4, up 0. Left 4, up 0. Okay, again, this is just getting you comfortable with the component form of vector. And finally, let's see here, I'll stop right there. It says write the component form of the vector that describes a straight line path from the car's current position to its intended destination. In other words, write that vector right there. Okay, so it's vector CD. And vector CD is the vector given by, well, again, 4, negative 12 to 10, 15. I got to go right 6. I'm looking at my x-coordinate. To go from 4 to 10, I got to go right 6. And then go from negative 12 to negative 15, I got to go down 3. So right 6, down 3 would be my component form of that vector. So again, this is a nice introduction lesson here into Chapter 9. Should be pretty simple for you guys. The only new material really is this idea of using vectors instead of coordinate rules. So again, as always, have any questions ready to go, and we'll pound some examples out tomorrow during class and go from there.